looking at problem 1, one way to evaluate this function is to actually plug in 2 into all the x's. So I would plug 2 into x to the third, and I would plug 2 into x. And that would work. You could also graph the function and do evaluate at 2, and it would give you the y value. Or you can use synthetic division. There's a little bit of a trick here, though. Do you see anything wrong with this polynomial, Anna? It's missing an x squared. Whenever it's missing a variable, you need to put a 0 placeholder in that spot. So 2 goes into the box, and my coefficients are 1, -1, 0, 6, and -7. Now, if it said x minus 2, then you change it into the root -2. But in this case, it actually says x equals 2. So we're going to use 2. But in the next set, we'll have to change it. Okay? So, Sadie, you all right with this? So I put this number in the box. Yes, I pulled, and then the 6 and the -7, but I had to put a 0 there because we're missing x to the second. So anytime one is missing, you have to put in a 0, yeah? We're just practicing synthetic division, yeah. So sometimes synthetic division can fulfill more than one role, and so this is just practice. But it might technically be faster to graph it. I mean, that's true. So in the end, we probably won't actually do this. We're just practicing the remainder theorem. All right, so we drop -1. 2 times -1 is 2. 0 plus 2 is 2. 2 times 2 is 4. So 10. 2 times 10 is 20. What? Wait, what? Oh my goodness. Thank you guys. Who's steering this boat? -2. So that gives me -4, which is 2, which is 4, which is 3. Now, I heard somebody say it didn't work. We're not trying to make anything work here. This is my answer. So f of 2 equals -3. That's what I was looking for. So in this first set, all you want to know is the remainder. So on my graph, wherever it is, at x equals 2, y equals -3. So 2, -3. And this is the number I was looking for. Okay, Sadie? So this times -1 goes here. And then this times -2 goes here. And then we bring that down. And this times that goes there, and we bring this down. And the last one is always our remainder. So on the first set, you're just looking for the remainder. Okay, that's really easy. Look at the second set, number 7. Number 7 wants to know, is x minus 2 a factor? How do we know if a number is a factor when the remainder is 0? For instance, is 3 a factor? Is 3 a factor of 23? Well, that's a bad. Apparently this heat is getting to me too. Is 3 a factor of 24? How do you know? Because 3 times 8, or you could also say, when you divide 24 by 3, you get remainder 0. Right? 8.0. Right? Remainder 0. But if I divide 24 by 7, I get 3 remainder 3. So anytime you get a remainder that's not 0, it means that it's not a factor. So for number 7 through 14, your answer is going to be yes or no. How do I know if it's yes or no? If you get a 0, the answer is yes, it's a factor. If you don't get 0, then the answer is no. So let's do number 7. Now, Hannah, this is where you have to make the change. What number goes in the box? Positive 2. Am I missing any variables? So we're dealing in k's this time. Are they all there? Yes, they're all there. So we don't need to have any placeholders. 1, negative 1, negative 1, negative 2. Are you okay with that, Sadie? Yeah? I mean, you know how we got this far? Okay. So we drop the 1. 2 times 1 is 2. You get that? 1. And then 2 times 1 is 2, which gives me another 1. 2 times 1 is 2. Remainder 0, which means it is a factor. Okay, wait. What does it mean to be a factor? Okay, put your pencils down. Now this is kind of a bad example, but let's suppose, so the answer to number 7 is yes. But let's suppose that this ended up being a minus 2. That means that there's another quadratic, x squared plus x minus 2, and the factors of that would be x plus 2 and x minus 1. And the other factor is this one. Oh, x is whatever. X minus 2. And what that means is these 3 factors create that cubic equation. Because if you times them all out, and it wouldn't really be this because I changed it a little bit. But so the roots of that, this graph is going to touch at 1, at 2, and at negative 2. So it would look like that. It has x equals negative 2 as a root, negative 1 and 2. No, 1 and 2. Which is kind of cool. So those are the factors. That's where the cubic equation comes from. Okay, so let's try. Which one? Okay, I would actually, let's do 13. 13 has 5 terms, but something's wrong with 13. I'm missing an x to the third. So I'm going to put negative 6 in the box because my factor is x plus 6, so my root is negative 6. And then what are my coefficients? 1. Oh, I'm looking in the wrong place. 6. And then 0 because I'm missing an x to the third right there. Negative 3, negative 22, and negative 29. So we drop the 1. Yes, well, whatever it is. If it was a 7, we'd still drop it. So the first coefficient always comes straight down. So negative 6 times 1 is negative 6, which is 0. 0, 0, 0, negative 3, 18, 4, no, negative 4, and then 24, which gives me a negative 5. So this one is a no. It's not a factor. And for this problem, that's all we care about. So for the second set, You're just doing synthetic division. If you get a 0, your answer is yes. If you get a no, anything other than 0, your answer is no. Okay. On the back side. So let's look at our 24 problem again. 24 thirds. Can I write that as a mixed number? What? 8. 8 and 0 eighths. So 8 and 0 thirds. And there's really a plus in there that we don't write. 8 and 0 thirds. But it doesn't make any sense to write 0 thirds. So we just write 8. Well, if I did 24 sevenths, now let's do 24 11. So this turned into a mixed number is 2 plus 3 over 11. 2 elevenths. Sorry. 2 and 2 elevenths. It went in 2 times remainder 2. So on the back side of this worksheet, we're just turning these into mixed numbers, basically. So let's do number 19. Negative 8 goes in the box. Am I missing any variables? No. So 6, 53, 32, negative 61, and 19. Oh, so I drop the 6, negative 50, nope, 48, negative 48, which gives me a 5, which is negative 40, negative 8, 64, 3, and negative 24, which is negative 5. So, I now need to write what the quotient is. So I did my division. Now I need to write the answer in equation form. So my original equation was b to the 4th. And I divided it by b, which would drop my polynomial from a 4th degree down to a 3rd degree. Does everybody understand that? So I took a b to the 4th, and I divided it by a b. So it has dropped down from b to the 4th down to b to the 3rd. So this is 6 b to the 3rd plus 5b squared minus 8b plus 3. But did it go in evenly? No, so I have to account for my remainder. So over here, when we had 2 remainder 2, I wrote 2 plus my remainder divided by my original divisor. So it's minus 5 over b plus 8. Because that was my original divisor. And this is, in essence, a mixed number. The graphs of these two polynomials are exactly the same. So you might ask, why do we care? Wait for it. We'll get there later. We're just practicing synthetic division for now. Okay, I want to find one that worked. That didn't make sense. Oh, hey, that's nice. Okay, let's do number 26. Oh, that's so nice. Yay. All right, look at number 26. Am I missing any variables? a 3, and a 2. So what goes in the box? Negative 4 in the box. So 8, 32, 0, another 0, 5, and 20. 26. So I drop the 8. 4 times 8 is 32. Oh, this is going to be so easy. 0, 0, 0, 0, 0, 0, 5, negative 20, and 0. What does that mean? Eight v to the 4th plus 5, and there was no remainder, so I don't need to write plus 0 over v plus 4. And I'm done. Okay, does that make more sense than yesterday? Okay.